Okay, we did linear equations last one. Let's do some quadratic equations, or at least just kind of intro. These are, I don't know, kind of straightforward ones. Let's start off with something really simple. Usually I would do this in the class and I'd ask people, like, what's the answer? And typically I'm going to hear 2. But there's 2 answers. There's not just one. -2 squared is also equal to 4. You see this square? That means it's not linear. That means typically you should set that shit equal to 0 and solve. Typically when you have a square, you should set that thing equal to 0 and solve. Because the answer is 2 and -2. That's the answer. Now, you could do this, because I know most of us were like, square root. What did I do wrong? There needs to be a plus or minus. Do you remember your plus or minus every time when you hit something with a square root? Is that something you have on lock? I found that to be one of the most, probably one of the biggest mistakes I see, or the most common mistake I see throughout a trigonometry class, is people use square roots and they forget to use their plus or minus. So I'm going to show you kind of a different way. There's a factoring piece called a squared minus b squared is equal to a plus b times a minus b. It's the difference of squares. Difference of squares. Difference squares. You know what I mean? It's a difference of squares. It's a good little trick. So I'm going to do that right now. Because I try and stay in the habit, anytime I have a square, I bring everything over to one side and I set it equal to 0 and I solve. So -4 and -4. And we're like, all right, so you got x squared minus 4 is equal to 0. But I want to use this. A squared minus b squared is equal to a plus b times a minus b. Well, oops. Well, what's 4? We got x squared minus, what's 4 squared? What is that? Isn't that 2 squared? Isn't that the same thing? X squared minus 4 is the same thing as x squared minus 2 squared? So isn't this just going to be, what, x plus 2 times x minus 2? X plus 2 times x minus 2 is equal to 0. Now we use what's called the zero product principle. This should be the last step typically when you're dealing with a quadratic. Typically, not always. But when you have a trinomial, it happens when this happens. So we're going to say if x plus 2 equals 0, the whole thing equals 0. So we'll set that equal. If x minus 2 is equal to 0, the whole thing will equal 0, right? Because 0 times anything is equal to 0. Subtract our 2 over and you're going to find out x is equal to -2. So add this one over and you get that x is equal to +2. There's our 2 solutions for a square. So it doesn't necessarily mean we're going to always get 2 solutions when you have a square, but it means you will get it. You'll get no more than that. Okay, simple one, right? You don't have to go through all that work, but knowing how to do it would be a good idea. Here we go. Here's another one. Straightforward. X squared equals x. What's the answer? You can just look at it and answer it. But again, there's a major mistake a lot of us want to make. Oh, but hey, is there anything we're not allowed to divide by? I'm just curious. Is there anything we're not allowed to divide by? We can't divide by 0, correct? Okay, cool. So I'm going to do this in red, showing you that this is a mistake. Don't do this. I see this a lot. You're dividing out an answer. What if x equals 0? What if x equals 0? Huh. So actually, I'm going to keep going, because, right, isn't 0 squared equal to 0? So if we were to do it this way, you'd say, oh, there it goes, and then just x equals 1. And that would be your only solution. But you can see that 0 works. The reason we don't do that shit is it every one of those stupid internet tricks is because you're dividing by 0. That's how come that shit works, and it's like, oh, magic. You're dividing by 0. You're not allowed to do that. So the way we're going to deal with this is you see that square, and you're like, dude, I'm going to move everything over to one side. I'm going to factor, then I'm going to solve. So you get x squared minus x is equal to nothing. Now we look and we factor. We're like, look, there's an x times x here. There's an x here. Anything in common? F yeah, there's an x. So factor out an x. So x squared divided by x is x. Negative x divided by x is -1. And bang, now we can use our zero product principle to solve. If x is equal to 0, the whole thing equals 0. If x minus 1 is equal to 0, the whole thing equals 0. Hence, we're going to get that x is equal to 0. And what's this one? Yeah, that's right, it's 1. And then there are our two solutions. Set it equal to 0. Factor it. Solve. All right. I'll bet you I'm going to get you on this on the test. I'm going to get well over half of our class on the first test for doing this. For dividing instead. Prove me wrong. Here's the trinomial game. This is a factorable trinomial. I'm not going to mess around with anything that's not factorable yet. The next one we'll go into quadratic formula and things of that manner. This factors. So the game becomes two numbers. That multiply to be negative 15. And add to be negative 2. Okay? That's that game with the trinomial. So you look at negative 15. You're like, let's break it down. Two numbers. You're like, I don't know. Come up with 2 that isn't 15 and 1. How about like 5 and 3? Oh, one of them has to be negative. And it also needs to add up to be, so let's do this. Negative 5 and 3. Negative 5 times 3 multiplies to be negative 15. Now, what's negative 5 plus 3? Negative 2. So, that's how we go through, and we want to try and factor, in case you've forgotten, a trinomial. So, since we found those two numbers, it breaks down as such. Negative 5 and 3. Positive. Right? Because negative 5 times positive 3 is negative 15, and negative 5 plus 3 is equal to negative 2. Now that we have it factored, we use our zero product principle. It tells us if x minus 5 equals 0, the whole thing equals 0, or if x plus 3 is equal to 0, the whole thing equals 0. Add over your 5, and you find out x is equal to 5. Subtract over your 3 and find out that x is equal to negative 3. So it's either x is equal to 5 or x is equal to negative 3. Oh. What we got? I think we have one more? We have one more. Here we go. X times x minus 4 is equal to 21. Hey, look, that left-hand side's already factored. But it's not set equal to 0, which does us no good whatsoever. Factored is dope when it's set equal to 0. When it's set equal to 21, it means get rid of those damn parentheses and let's kick everything over to one side. So let's get rid of these parentheses. X times x is equal to x squared. X times negative 4 is equal to negative 4x. And we're equal to 21. Let's kick that 21 on over to the left-hand side. Set it up like we just did that problem before. And we're on our way. So subtract 21 and subtract 21, balancing out that scale, giving us that x squared minus 4x minus 21 is equal to 0. Notice I'm writing in descending order, squared the x and then the number. Let's see if we can do it. Let's set it up into that factor. And remember, not everything factors. You hope it does. So we need two numbers multiplied together that equal negative 21. And they sum to be negative 4. I think that's going to be negative 7 and positive 3. Negative 7 times positive 3 is negative 21. Negative 7 plus 3 is equal to negative 4. Now we use our zero product principle. Set them, each of our factors, equal to 0. And we find out that x is equal to 7. Or we have that x is equal to negative 3. And there you go, my friends. We found some more solutions. All right, in our next one, I'm going to come back with some that aren't quite as easy. Like let's throw a leading coefficient on that x squared. Let's do the quadratic formula. Let's do some other stuff. So we got a couple more when it has to do with this algebra. See you in the next.